This is a continuation of the 4.2 notes. It's about Pascal's triangle, which is this pattern that you see on the screen right now. And I'd like you to pause and take a moment, study what's going on there, and try to figure out what the next row is. So the next row, if you tried it out, would be this. Now, if that's what you got, then you probably can do the next one. If you didn't get that row, study it again and see if that helps figure out what the next row is. So I get this for the next row. And if that's what you got, then you're doing great. If you didn't get that, that's okay. I think you'll see the pattern very soon if you don't see it yet. There's a pattern going on. Of course, lots and lots of patterns going on here. Like, for instance, this column down here, 1, 2, 3, 4, 5. Obviously, those are all ones. And 1, 3, 6, 10, those are some types of numbers, going up by 2, then by 3, then by 4, then the next one would be by 5, of course. And this one over here going up by 3 and then by 6, and we'll see what the next part does. But let's do one more row, and let's see what you can do. Now, where am I getting these numbers? I'm hoping that you're seeing that what's going on in Pascal's triangle is a simple pattern that's having the numbers above add up to the number below it. So, for instance, 1 and 5 makes 6, and 5 and 10 makes 15, and 10 and 10 makes 20, and 10 and 5, and so forth. Anywhere you look on here does the same thing. 1 plus 2 is 3, and 1 plus 1 is 2. And you think, well, this is wonderful, but who cares? That's maybe what you're thinking, which is fine. But Pascal's triangle does kind of an interesting thing. It helps us expand binomials. So, for instance, if I wanted to get the binomial x plus 1 to the first power, these would be the coefficients of it, 1x plus 1. If I wanted to expand the polynomial 1x plus 1 to the second power, the answer would be x squared plus 2x plus 1. And if I wanted to do x plus 1 to the third power, it'd be 1x to the third plus 3x squared plus 3x plus 1. And you can confirm that by multiplying x plus 1 times x plus 1 times x plus 1 and so forth. And any row of this thing, and by the way, this is x plus 1 to the 0 power, which is just anything to the 0 power is 1. So it helps you with expanding x plus 1 to whatever power it is corresponding to the row. But we'll see how useful that is for things beyond x plus 1. So let's take a look and see what it really looks like. Okay, let's see. Oh, do I get my screen back? Try again. I don't know how to get off of that. All right, so here's Pascal's triangle another way. You can look them up and find out why somebody in the 16th century was learning about this kind of stuff. But that's Pascal's triangle. So if I was using x plus 1 to the 6th, as I was showing you before, I would use the 7th row, because the first row is the 0 row, and the first row is the second row is x plus 1 to the first. So here's the 7th row, and I would put the numbers in descending order. The exponents go x the 5th, x the 4th, x the 3rd, and so forth, all that. All right, so how do you do something like 3x plus 4 to the 4th power? Well, obviously you'd use the 5th row, which is this one. And those are coefficients, but the thing is that we've got to figure out what to do with these other. Instead of having x to the 4th and x to the 3rd and x to the 2nd, now I have 3x to the 4th and 3x to the 3rd and 3x to the 2nd. And instead of having 1 to the 4th, 1 to the 3rd, 1 to the 2nd, and so forth, with the 4, I've got 4 to the 4th and 4 to the 2nd and all that stuff. So here's the way it works. The 1 is going to be multiplying 3x to the 4th power plus 3x to the 3rd power, and 6 times 3x to the 2nd power, and so forth. That's how I'm using the the 1, 4, 6, 4, and 1, and the 3x. Now, if you looked at all the other problems, the last part of it was the fourth power and so forth, going all the way back up. So what it's going to do is this. It's going to go backwards. I'm going to have 4 to the fourth, 4 to the third, 4 to the second, 4 to the first, and 4 to the 0, which is just 1. Because you know that the first problem, if I was to multiply 3x plus 4 to the fourth power out, it would get 3x times 3x times 3x times 3x. That's the 3x all to the fourth power. So if I just multiply this whole expansion, this is, I'll get the answer for this particular problem. So I took 3 to the fourth power and so forth, 3 to the third power times the 4, 3 to the, I'll go back for a second. So for instance, in this one, 3x to the third power, it's 3 to the third power is 27, times the 4 makes 108. That's where that came from. 3 to the second power is 9, times the 6 is 54. 3x to the 3 to the first power is 3, times the 4 makes 12. So that's where those came from. Now I'm going to just make this 4 to the first, 4 to the second, 4 to the third, 4 to the fourth, and they get multiplied. So 4 to the first, of course, is 4 times 108, and 4 squared is 16 times 54. 4 to the third is 64 times 12, and 4 to the fourth is 256. And that's our answer. That's how to use Pascal's triangle. If you're at all interested, there's more to study on that. It's not the most important thing in the world, but it's kind of interesting how it helps you expand binomials.